Astronomers breathed a collective sigh of relief as the James Webb Space Telescope, or JWST, sprung to life. Getting the $10 billion telescope up and running following its launch on Christmas Day 2021 had been a nerve-wracking affair. JWST would not fit into any modern rocket without being folded, and it had to rely on hundreds of moving parts to unfurl to full size once in space. Ultimately, those efforts were successful, and the telescope has started returning some of its first calibrated images to thrilled audiences back on Earth. Yet the experience left many astronomers wondering if there was a simpler way to build and launch telescopes of this size. "We were worried about the unfolding," says John Blevins of NASA's Marshall Space Flight Center. "But with a larger rocket, you don't have to unfold in space, you can do it on the ground." As chance would have it, two such rockets are currently sitting on launch pads. Each should ultimately exceed the power of the mighty Saturn V, which sent the Apollo astronauts to the moon. The first, NASA's Space Launch System, or SLS, is ready and waiting at Kennedy Space Center in Florida for its inaugural uncrewed voyage around the moon as part of the Artemis 1 mission, the opening shot in NASA's plan to return humans to the lunar surface in the 2020s. The rocket, tentatively scheduled for a launch in late this month, is meant to be as reliable as possible and therefore based in large part on legacy hardware from NASA's Space Shuttle program. But reliance on tried-and-true technology could be the Achilles heel. Some estimates currently peg the SLS's cost at an eye-watering $4.1 billion per launch. Presuming it is not scuttled by congressional appropriators feeling buyer's remorse, its massive size could eventually be a boon for scientists seeking to send larger, more ambitious spacecraft and telescopes throughout the solar system, and even beyond. However, it can't. On the other side, over in Texas, there's Starship, a very similar, capable, but wildly different rocket being developed by SpaceX, also in preparation to launch on its first orbital test flight pending regulatory approval from the Federal Aviation Administration. The cost of the SLS seems so egregious because each multi-billion-dollar rocket will be discarded after a single use, its components relegated to the seafloor as junk or left adrift in space. Such was the standard for most of the space age, but times have changed. Starship and its giant super heavy booster are instead built for endurance, landing back on the ground for rapid reuse similar to SpaceX's current fleet of Falcon rockets, which has already dramatically lowered the cost of reaching space. For this big advantage of Starship, the famous astrophysicist Neil deGrasse Tyson said that any demonstration of rocket reusability is a good thing, and even stressed that reusability is arguably the most fundamental feature of affordable, expensive things. As big and bold as the SLS may be, experts say it pales in comparison with what Starship could achieve. Starship holds the promise of transforming the solar system in a way we can't really appreciate, says Alan Stern of the Southwest Research Institute in Texas, who helms NASA's New Horizons mission, which flew by the dwarf planet Pluto in 2015. It completely changes the game. Starship, by its design, can be refueled by other Starship vehicles in Earth orbit. That means it could hypothetically carry a huge amount of mass around the solar system. You could get a 100-ton object to the surface of Europa, SpaceX's CEO Elon Musk said in a public meeting of the National Academies in November 2021. This is a 5 times greater performance than the very best SLS can offer, even in its final configuration with a kick stage. Starship is also forecast to be significantly cheaper, although whether it can hit Musk's optimistic projection of less than $10 million per launch remains to be seen. If they get anywhere near that cost, it's kind of an analog to a 747 and a shipping container all in one, says Robin Haig, former head of launch at the UK launch company Skyrora. That's going to be used throughout the whole solar system. With 1,000 cubic meters of usable volume, Starship is also big enough to fit the entire Eiffel Tower disassembled, though not powerful enough to lift it into orbit. The gargantuan capability left Heldman and her colleagues to publish a paper on what sort of equipment Starship could carry to the lunar or Martian surface. Refilling Starship in orbit effectively resets the rocket equation, allowing for large payloads to be transported to the Moon and Mars, they wrote in a reference to the fact that the more mass you want to launch, traditionally, the more thrust you need on an exponential scale. Starship is not limited to these destinations, though. It is not fine-tuned to either the Moon or Mars, says Margarita Marinova, former senior Mars development engineer at SpaceX. The goal for Starship is to create the more generic, larger-scale exploration capability. Ideas include launching full-size drills rather than pint-sized versions. You can put a 100-foot, 30-meter drill on the vehicle and then just deploy it, Hellman says. You don't have to try and fold it up. That's exciting because you can drill down into ice on Mars, which is very important for sustaining human exploration and also the search for life. Starship could conceivably also offer a two-way delivery service, returning vast quantities of material to Earth from these and other worlds. We've always been very cautious about the samples we return because we've been limited by the amount of mass, Hellman says. With Starship, you can just load up the vehicle with rocks and ice and whatever else you find. The theory physicist Dr. Michio Kaku, in an interview with Fox Business's Varney and Company, complimented that, well, look at it from Musk's point of view. Kaku replied in reference to SpaceX founder Elon Musk. He says, look at the dinosaurs. The dinosaurs did not have a space program, and that is why there are no dinosaurs in the room now, he joked. We do have a space program. We can avoid killer asteroids. In fact, next month in November, NASA will send the first rocket to deflect an asteroid into outer space. Meanwhile, Martin Elvis of the Harvard-Smithsonian Center for Astrophysics and his colleagues have written a white paper on how Starship's unique capabilities could be used to launch a wide variety of next-generation space telescopes. One idea is an extension of the Event Horizon Telescope, a virtual observatory on Earth used in 2019 to capture the first image of a supermassive black hole. In a single launch, Starship could send a stack of 6-meter telescopes into space, allowing for the creation of a much larger virtual telescope. That could provide views of thousands of supermassive black holes found at the center of galaxies like our own, Elvis says. Starship could also launch a large telescope custom-built to image Earth-like exoplanets around other stars, as recommended to NASA by the National Academy's Astronomy and Astrophysics and Decadal Survey in November 2021. The diameter of mirror of the Decadal report suggested was 6 meters, which is about the same as the JWST, Elvis says. But with the super rocket's large payload fairing, such a mirror could be monolithic, without any need to unfold and deploy in space, probably resulting in major cost savings and a speedier path to the launch pad. That would simplify the design dramatically, Elvis says. Finally, as Elon Musk promised, a successful orbital flight could be 1 to 12 months from now. All scientists hope that it's happening sooner rather than later. Starship, which is being built at a Texas site dubbed Star Base, consists of a giant spaceship on top of a large booster known as Super Heavy. Both can land back on Earth so they can be reused, reducing cost. The entire vehicle is capable of lifting 100 metric tons or 220,000 pounds of cargo and people into space on a regular low-cost mission. The volume of usable space within Starship is a whopping 1,000 cubic meters. That's big enough to fit in the entire Eiffel Tower disassembled. For most, this massive size is admirable. However, the Mars Society president and aerospace engineer Dr. Robert Zerbin said that a problem with Starship is that because it's so massive, it takes a great deal of facilities to be able to refuel it. So I anticipate that the few Starships that first land on Mars will stay on Mars. To begin the Mars colonization effort, the rocket company's mission would be to deliver a massive amount of cargo, including vital equipment to Mars, and possibly robots with capability to set everything up before the first human arrives. Part of the first deliveries to Mars could include supplies like power generators, large batteries, and solar panels that would aid to build and power a propellant plant to refuel Starship, so it could eventually come back to Earth. Zerbin pointed out that would take 6 to 10 football fields of solar panels, and that's just enough to refuel Starship within a 500-day stay on Mars. Starship is capable of carrying 100 passengers plus 100 tons of cargo. Zerbin believes the first missions will not transport 100 passengers, that a crew of about 20 astronauts to set everything up is safer to prepare for future arrivals of over 50 people. Zerbin says building a mini version of Starship to send to Mars has a better advantage to sending it and bringing it back to Earth. It would have a tremendous advantage for an exploration architecture because it wouldn't need a big base in order to refuel and come back. He, Musk, Musk was adverse to that. He feels that developing one thing is much better than developing two things. But Zerbin believes SpaceX is capable of building both versions of the Starship, a full-scale and a mini, especially seeing how quickly they develop things. Besides, he explained that landing a Starship on Mars will have some issues. Zerbin believes landing a Starship on the Moon will not work because it will have a gigantic plume upon landing and it would blow a crater, he says. It wouldn't land, it will dig a crater and fall over, explaining that both the Moon and Mars need to have landing pads built beforehand to land a massive vehicle such as Starship, so they can take the plume of the Starship. On Mars is a bit of a less problem, but it's still a major problem. If that can't be resolved, then he may be forced to go to the mini Starship route. Zerbin further stated, in order to land a Starship on the Moon, someone has to go there first and build a landing pad, so it's not blowing debris all over the place and building a crater to fall into. That's not good architecture. It just isn't. Zerbin believes there's also other issues with the Starship architecture. For instance, the Starship is a stainless steel hull and he can do the entry from Earth orbit from that because it's a low ballistic coefficient which reduces the heat load, so he can do this with a steel ship without heat-resistant tiles or anything of this sort. But coming back from Mars is a much higher heat load than coming back from LEO, so he has to make specialized starships that are reinforced thermal protection. Adding that Earth-to-Earth version of starships would work. Surface-to-surface transportation is great. Besides, the famous Professor Brian Cox also doubts Starship abilities. Musk said manned missions would happen by 2029 on Starship, but Cox doesn't see that as plausible. SpaceX is a remarkable company. They did do something astonishing, which is transforming the economics of spaceflight. You never know with them. They're really good engineers, but my guess is Musk's prediction is optimistic. Professor Cox said he'd also not go to Mars tomorrow, even if SpaceX technology existed. I'd be surprised to see anyone there before the 2040s at the earliest, although I'd love to be wrong, he said. I think it's even more difficult than going to the Moon was in the 60s. Apollo was at the edge of our capabilities in the 60s. It was right at the edge of available technology, and I think Mars is perhaps even slightly beyond that at the moment. I wouldn't be surprised if we've started sending the infrastructure within the next 10 years. Well, these doubts are completely understandable as Starship isn't real yet. All eyes will be on the first orbital launch test expected sometime in the coming months. Even if it is a success, no one knows whether SpaceX will be able to achieve its vision of launching the rockets daily and reusing them many times. Also unsettled is whether a market will materialize for a rocket that could put so much into orbit. Gladly, while some scientists are worried about Starship, the majority are in favor. Even world-renowned physicist Dr. Mikio Kaku agrees with Musk's opinion. As an insurance policy, we have to make sure that humans become a two-planet species. And now, of course, Elon Musk has revived this vision by talking about a multi-planet species. Even Neil deGrasse Tyson, who calls himself one of SpaceX's biggest critics, also believes that Musk's SpaceX Starship orbit project has more merit and has a higher chance of going beyond orbital flight. The concept of SpaceX is we want to send people to places. It's an effort to push that limit, the frontier of exploring space. Starship could fly bigger and heavier instruments more often and much more cheaply if SpaceX's projections of $10 per kilogram cargo launch cost are to be believed. On Mars, they could deploy rovers not as one-offs, but in herds. Space telescopes could grow, and fleets of satellites in low Earth orbit could become commonplace. Astronomy, planetary science, and Earth observation could all boldly go better than they ever have before.
So it's really a spectacular piece of engineering, extremely difficult to make and succeed. Engine has been mind-bogglingly difficult, but it is essential, obviously, to making Starship work.
This is definitely the reason SpaceX must continuously switch over from the version of Raptor that was used on Starhopper. SN5, SN6, SN8, SN9, SN10, and SN11. Raptor version 1.0 and the version of Raptor used on SN15, S20, and B4. Raptor version 1.5 into the next generation of Raptor, Raptor 2. The new version has definitely a large number of performance and reliability improvements that's totally thrilling scientists' minds. While Raptor 1 has been refined over the years, it's now an old design. Its construction is complex, difficult to manufacture, and has long turnarounds between launches. It also has hit a thrust ceiling of 185 tons, meaning it will struggle to reach Elon Musk's demand for a Mars-bound Starship. SpaceX's solution is Raptor 2, an engine capable of taking us to Mars and beyond. This isn't just an updated Raptor 1, but an entirely new design from the ground up that can outstrip its predecessor in every measurable metric. But first, let's look at similarities. SpaceX cast Raptor engine parts from supersteel alloys. Inconel is a family of austenitic nickel-chromium-based superalloys. Inconel alloys are heat and oxidation-resistant materials. Inconel has been used for over 60 years in rockets and space planes. The skin of the X-15 rocket-powered aircraft was made out of Inconel tin. The X-15 first flew in 1959. Inconel X-750 was used for the thrust chamber of the F-1 rocket engine used in the first stage of the Saturn V. The space shuttle used 4 Inconel studs to secure the solid rocket boosters to the launch platform. 8 total studs supported the entire weight of the ready-to-fly shuttle system. SpaceX has used Inconel in the engine manifold of their Merlin rocket engine and the Falcon 9 and the SpaceX Super Draco rocket engine for the Dragon V2. There's no information to suggest that these have significantly changed between Raptor 1 and Raptor 2. The engine relies on a small amount of 3D printing. However, SpaceX is trying to remove as much 3D printing as possible due to the inability to scale, the high cost, and the low manufacturing rate. Raptor 1s use methane and liquid oxygen fuel, making it one of the cleanest burning rockets available. Thanks to these high-thrust engines, precise throttle, and gimbal ability, SpaceX has pioneered self-landing rockets. Raptor 2, still methane liquid oxygen engine. But that's where the similarities end. At the beginning of 2022, the first Raptor 2 was spotted, marking the end of Raptor 1. After Raptor 1 production began, SpaceX stopped producing all Raptor 1.5 engines. Compared to the original Raptor, Raptor 2 looks borderline incomplete. A large amount of plumbing and sensors have been removed, transitioning the engine from a Christmas tree look to a significantly cleaner look. On the original version of Raptor, while SpaceX was learning how to control the engine, a very large amount of development sensors were needed, allowing them to track pressure and temperature throughout Raptor's plumbing. Additionally, many valves were combined into valve plates, helping further simplify plumbing. By removing a large amount of these components, SpaceX has made the engine more flame and heat-proof, a clear step toward SpaceX's goal of removing all engine shrouding from the booster, which would decrease the booster's mass by somewhere around 6 tons. It's a clear example of Musk's "the best part is no part" mantra. Another change made to Raptor 2 to further decrease the engine's mass is removal of the torch igniters in the main combustion chamber. Instead of relying on redundant torch igniters, the well-mixed hot oxygen gas and hot CH4 gas act hypergolic under the high temperature and pressure of the main combustion chamber, or MCC. Raptor 2s are also welded together, effectively reducing the number of components that are needed. This makes the engines more compact, lighter, and easier to manufacture than the Raptor 1, which uses flanges to literally bolt the engine together. Raptor 2 also has fewer flanges than the original versions of Raptor. Flanges are great during prototyping when parts have to be swapped out, but they increase mass and increase pressure loss throughout the engine. Now that the design is more stable, SpaceX has been able to remove many flanges on the engine, going as far as hoping to remove all flanges on Raptor 2.5, which will further increase thrust to 250 tons and debut on Booster 12. Finally, the Raptor 2's pre-burner controls are no longer spread all over the engine like on a Raptor 1. Instead, they're in their own box. This simplification makes manufacturing easier and means the shroud could be removed, allowing for more movement in gimbaling engines. So what do all these changes add up to? Well, the Raptor 2 has already produced 247 tons of thrust during static test, and engineers are confident they'll hit 250 very soon. That's a 35% increase in thrust from a smaller, lighter engine. This will allow any Raptor 2-equipped rocket to have dramatically increased payload. But it just doesn't stop there. Thanks to Raptor 2's simplicity, it can be relaunched within an hour compared to Raptor 1, which required several weeks between launches. This simplicity also means that the Raptor 2 cost half as much to manufacture as the Raptor 1. To say this engine is groundbreaking, it's an understatement. The impact of Raptor 2 will be immense. Let's look at Elon Musk's ultimate goal, colonizing Mars. Thanks to Raptor 2's quick turnaround, a small fleet of Raptor 2-equipped starships could launch several times a week. This means SpaceX could launch more payloads into space in 1 year than the U.S. has done in its entire history. The dramatic increase in annual payload capacity is what will enable SpaceX to colonize Mars. Musk estimates a total of 1 million tons of payload will be needed to set up a self-sustaining Mars colony. In theory, Raptor 2-equipped starships could deliver this much to Mars in just 10 years with about 20 launches a week. That means it may only take approximately 1,000 or so Raptor 2-equipped starships working full-time for a decade to colonize Mars. As you can imagine, this will cost an awful lot, but that's where the Raptor 2 really shines. A Raptor 2-equipped starship is estimated to cost only $2 million per launch. Compare that to NASA's SLS, which is around 15% smaller payload and cost around $1.55 billion to over $2 billion per launch. For some perspective, Musk's hypothetical 10-year Mars colonization project would cost $2.08 billion a year, which is the cost of one SLS launch. Or to put it another way, Starship is 1,040 times less than the SLS. Just a reminder that the SLS is no slouch. It is a cutting-edge rocket designed by the very best at NASA. It's just that Starship and its Raptor 2 engine is just in another league. Starship could really unlock the Moon, Mars, and the asteroid belt for further human exploration and colonization. With such an impressive payload, low launch cost, and quick turnaround, Starship could also significantly impact the Earth. As the Raptor 2 can run off carbon-neutral biofuel, Starship could, in theory, be the world's first net-zero rocket. Combine that with the impressive landing ability and LEO, or low Earth orbit payload, of over 150 tons, and you have a possible replacement for commercial jet planes. It would take Starship 29 minutes to go from London to New York, and only double that of a regular first-class ticket per passenger. This service would be impractical with Raptor 1's long turnaround times, but a Raptor 2-equipped Starship fleet could easily shuttle passengers to and from without massive delay. So thanks to the Raptor 2, SpaceX could revolutionize aviation as well. It was truly a historic moment for the rocket industry. April 11th, 2019. The minute the launch window opened, the rocket boosted its payload, a Saudi Arabian telecommunications satellite, toward geostationary orbit. Even across several miles of water, the power of 5 million pounds of thrust was enough to rattle your rib cage. One nearly had to shout to be heard over the roar of the 27 Merlin engines as the rocket departed the launch pad. But few felt the need to say anything. Instead, most of the viewers were on with the causeway, casting their eyes to the sky, tracking the rocket between breaks and the low-hanging clouds as it boosted a 13,000-pound satellite thousands of miles above the Earth. Less than 8 minutes after the launch, the rocket's two side boosters appeared overhead, looking like two building-sized candlesticks in the twilight sky. As the rockets executed their final burn to perform a nearly simultaneous landing, two sonic booms ripped through the otherwise peaceful Florida night. Everyone on the causeway erupted in cheers after it was clear that both boosters had successfully landed, the tops of which could be seen just over the trees. More incredibly, only a few minutes later, the center core attempted a landing on the Of Course I Still Love You, a drone ship parked in the Atlantic Ocean 600 miles from the launch pad. But the booster eventually toppled into the sea because the drone ship lacked adequate clamping for the heavy core. A handful of spectators were listening to the radio broadcast from the Launch Command Center, waiting to hear the fate of the center core. The 2 minutes between the side booster landing and the center core's attempt was tense. During Falcon Heavy's demo flight in 2018, the center core landed in the water, and the resulting explosion damaged the drone ship. The botched landing was due to insufficient fuel to light some of the engines. CEO Elon Musk later revealed, but said the fix is pretty obvious. Whatever obvious fix Musk and the SpaceX crew employed that time around clearly worked. The center core nailed its landing on the drone ship, and once word made its way from the SpaceX command center, the journalists and photographers assembled on the NASA causeway went absolutely wild. Only a few years ago, the idea of landing a rocket booster was unthinkable. At that point, SpaceX had aced a landing with 3 boosters from the same rocket. Well, it's definitely not an easy task. Falcon Heavy's center core, as is fairly visible, is dramatically different from the Falcon 9 booster SpaceX is used to reusing, including a range of connection hardware that's absolutely flight critical and protrudes rather aggressively into the rocket's often violent airstream. In other words, Falcon Heavy center cores could get far more toasty than the Falcon 9 or even their side booster companions, potentially damaging hardware that simply has to be perfect for Heavy launches to succeed and do so reliably. Honestly, since that wonderful landing, SpaceX has not recovered the center core once. In the third flight that happened in June of 2019, after a smooth takeoff, the Falcon Heavy's boosters separated and headed back to Earth. The center core attempted a more difficult landing, aiming for the drone ship, Of Course I Still Love You, stationed in the Atlantic Ocean. It missed the drone ship, with the live stream showing the rocket coming in for landing, zooming past the pad, followed by a fireball erupting in the distance. As noted by both CEO Elon Musk and several SpaceX engineers-turned-webcast hosts, aside from the fact that the overall mission was by far the company's most challenging yet, Center Core B-1057's recovery was also expected to be the most challenging booster landing ever. The booster's landing target was drone ship O'Sisley, stationed at a record-smashing 1,240 kilometers or 770 miles off the coast of Florida, almost 30% further than any previous recovery attempt. Sadly, SpaceX either chose not to broadcast the center core's onboard camera during re-entry, or the booster could not maintain a downlink connection during the ordeal. However, based on the basic info that was included in the webcast, B-1057 completed its boost burn and separated from the upper stage in Space Test Program 2, STP-2, the payload, some 3 minutes and 40 seconds after lifting off from Pad 39A. At MECO, main engine cutoff, the building-sized booster was traveling a blistering 3.1 kilometers per second, or Mach 9, at an altitude of more than 120 kilometers. In short, the brutal heating and buffeting of hypersonic atmospheric re-entry damaged the rocket's central M1D engine necessary for an accurate controlled drone ship landing. Incredibly, B-1057 actually appeared to make it almost all the way to successful recovery, veering off course just a few hundred meters above Osley. Musk also noted that this may have actually been an instance of the rocket's autonomous guidance computer intentionally aborting a landing attempt to protect the drone ship. It's possible that the re-entry didn't fully destroy components, but rather damaged them to the point that they failed only after sustained landing burn. Anyway, it was a particularly long mission, with the Falcon Heavy second stage having to complete 4 separate burns to deliver its payload to 3 distinct orbits over the course of 3.5 hours. Center core booster explosion aside, the third flight of the Falcon Heavy was another historic moment in SpaceX history. Falcon Heavy's most recent flight didn't recover the center core of the rocket. This was just the 4th launch of the Falcon Heavy rocket, and the first stage did its job, delivering the upper and 2 payloads for the U.S. Space Force into orbit. The Falcon Heavy hasn't flown a mission since June of 2019, partly due to the lack of demand, but mostly because of payload readiness. The USSF-44 mission that launched Tuesday morning was originally scheduled for December 2020. Another Space Force mission on the Falcon Heavy, USSF-52, was originally supposed to fly in October 2021. NASA's Psyche asteroid mission was supposed to fly in September, but was also delayed after the payload wasn't ready. But now that this Space Force mission has flown, the rocket's cadence should increase significantly. As many as 8 to 10 flights of the large rocket could occur between now and the end of 2024. Including some high-profile missions for the U.S. government, notably NASA's $4 billion Europa Clipper spacecraft due to launch in October of 2024. Both the Department of Defense and NASA are now entrusting some of the most valuable payloads to this complex and relatively new rocket that made its debut in 2018. Hopefully during these flights, SpaceX will successfully recover the center core of Falcon Heavy, the scene that seems only in a sci-fi fiction film. And that about wraps it up for today's episode. Hey, don't forget, share your ideas in the comments section. Your support motivates us to create more quality video. And for that, we thank you so much and hope to see you next time.